Hello. Today I have the dubious pleasure of providing an in-depth explanation to the most missed question on Chem 1442 Exam 3, and it reads, phosphoric acid, H3PO4, is a triprotic acid with the following acid dissociation constants at 25 degrees Celsius. Ka1 is equal to 7.5 times 10 to the negative 3. Ka2 is equal to 6.2 times 10 to the negative 8, and Ka3 is equal to 4.8 times 10 to the negative 13. What is the value of Kb for HPO4 2 negative? Now, in order to answer this question, it is imperative that a firm understanding of the relationship between Kw, Ka, and Kb be established. Kw, which is the autoionization energy of water or water autoprotolysis constant, has an understood value of 1.0 times 10 to the negative 14, and it is equal to the product of Ka, indicative of the concentration of hydronium, and Kb, which is a representation of the concentration of hydroxide present. The relationship between Ka and Kb is portrayed by the fact that when a weak base accepts a proton, emphasis on weak base accepts a proton from water, the resultant equilibrium has its own equilibrium constant, Kb. So when the question asks, what is the value of Kb for HPO4 2 negative, it is asking for the relationship between Kb value and the second deprotonation of hydrogen with respect to H3PO4, which means the second Ka is equal to 6.2 times 10 to the negative 8, should be used in conjunction with Kw to determine the Kb value of HPO4 2 negative. Therefore, Kw is equal to the concentration of Ka2 times the concentration of Kb for HPO4 2 negative. Rearranging this equation, we have 1.0 times 10 to the negative 14, which is the value of Kw, divided by 6.2 times 10 to the negative 8, which is the value of Ka2. We have Kb for HPO4 is equal to 1.6 times 10 to the negative 7 when this is put in the calculator. And this is your answer. As one of my chemistry instructors always says, answer the question that was given or was asked, because far too often students use the wrong Ka values when solving for Kb. Another way in which this question could have been presented was to determine the Kb value for PO4 using the Ka value of the previous questions. In this case, Kb is equal to 1.0 times 10 to the negative 14, which is the Kw divided by 4.8 times 10 to the negative 13, which is the value of Ka3 from the previous question. And the answer you get is 2.0 times 10 to the negative 2. And as you will notice, that is also an answer choice from the previous question. So again, I cannot stress how important it is to answer the question that was asked.